Okay, I think you can hear me. I just realized that I left a fan on, so I need to go turn that off. I'll be right back. Okay, that is better. All right, welcome everybody. How's everybody doing today? I have all of my kids at home, but I have turned on the longest Harry Potter movie for them. So hopefully they stay put. This morning I got a makeover during 2 of my meetings by my 5-year-old. I still think I have not gotten it all off my face. Hey, Nick. Wow, trying to type. So today we are going to be talking about image tensors, and I'm really excited because we're going to be getting into some fun new parts of the book. So I guess let me introduce myself. Go ahead and get it started because I have to go to school and pick up some stuff for my kids for their learning. So I'm Becca. I am a front-end developer and I am learning how to live stream while I learn TensorFlow.js. And I am using Gant Labord's book, Learning TensorFlow.js, Powerful Machine Learning in JavaScript. So we are actually on chapter 4 already. I think Gant will probably make an appearance on the live stream sometime soon, or, well, the holidays are coming up, so maybe sometime after that. But we are going to make it into some cool stuff in the next coming weeks, and I am going to continue to stream on Tuesdays at 1 p.m. We have a TensorFlow.js study group, so if anyone's interested in that, I'll make sure that I get that link to you. Just let me know. Every stream we do a giveaway, and so shout out to our winners of the last 2 streams. Nick Taylor won last week, 2 weeks ago, and Pachi won last week. And this week we're doing another giveaway. We have Gant is giving away a book, and I believe he has signed all of those books. Oh, now I'm trying to remember. I think it's a dragon with a glowing ball bookmark. It was something cool. And I think another pin. I might have gotten that wrong. So if you win and those are not the things that you got, I am sorry, but you will definitely be getting a book. You can check out my Twitter. I have on there what I posted the clip from Gant because he also has clips for every single week of his giveaways, and they're worth watching all by themselves because Gant is super fun. So let's see here. I think we should just go ahead and dive into everything that we're looking at. So let me figure out how to do that. All right. So, big shout out to Nick for showing me how to get the chat up there in my stream, so that gets recorded too. I worked on a new layout for a couple of hours yesterday, and then OBS crashed, and it did not save my work. So it's okay. I kind of like this new way of having things set up. You can find me at BeccaHW at all of these places and more. Thanks, Nick. OBS is lucky that I did not break it yesterday or totally give up. So these are the things that we're talking about today. I thought it'd be nice. Oh, okay. So if I move this window, then it also moves what we see in OBS. So I'm going to be very careful to not change the size of that, but I think I made it smaller than it was. So let's go back to it. There we go. A little bit bigger. Can you get a little bit bigger? Whoa. Whoa, now it's eating my face. And now I know how I should line things up. All right, this is interesting. Learning something new every single time I stream. So that is awesome. Okay, so we are talking about images and tensors. I'm going to go ahead and throw the code sandbox link into the chat. So if you want to follow along with that, or if you want to fork it and play around with it, you can do that too. And let's see what we've got here. Okay, so these are some of the things that we're trying to figure out for this week. We want to, or well, today, I guess, because it is this week on the stream. Today, want to know, how do we make an image a tensor? Why you would want to make an image a tensor? Some common ways to manipulate images and why we would want to do that, and some of the methods that we're working with. And so I find that when we're working with learning about image tensors and image classifications and stuff like that, I like it because it gives me something really tangible to understand. We can literally see what's happening as we go through and we do this. And so what we do know about images is they're made of pixels, right? And so each color, or in colored images, each pixel is represented by an array of 3 numbers. So you might have heard RGB, so red, green, and blue. Those are the 3 primary color channels. And together that's used to decide the color of the pixel. Sometimes you'll see RGBA, or a 4th value in that array, and that last one, that is the alpha parameter. That is the transparency of the color. So it goes from 0 to 1, with 1 being totally transparent. And so if you see that, that's what you are looking at. I'll go ahead and drop this link to, this is a CSS tricks page that talks about that, which is really nice. I like CSS tricks. They have a lot of nice breakdown of everything that everything that I want to know about CSS, and they always have some really good examples there. So one of my favorites. So, okay, so we have these pixels, and when we turn an image into a tensor, those pixels become part of the tensors, become a tensor. And so it's like a translation of the data. So it goes from pixel to tensor, and we do that so we're able to use it with TensorFlow, with these models, with the different methods to manipulate it. And we'll get into a little bit of that here shortly. Let's see. What else? Okay, so why do we want to manipulate tensors? Well, so we did, how do we make an image a tensor? Well, we take those pixels and we use a method that we'll go over later to make it into a tensor. Why would we make an image a tensor? So again, like, we're going to be using this with models, but when you're training those models too, you want to create a data set. And that data set helps you can have the training set. And so to train something, you want good data. And so I'll give an example of last year. So last year he was 11, and my son was doing science fair. And so we did a machine learning science fair project. It's one of the popular ones. Now I can't remember what it's called. But you train your computer to look at cereal and sort whether or not it's a marshmallow or a piece of cereal. So we were looking at Lucky Charms. And to train it, we had to create the data sets. So it could tell what was a piece of cereal and what was a marshmallow. And when we have data sets, we want them to be, pretty complete. So it doesn't only see a piece of cereal that's standing upright, because that cereal might fall out of the sorter and it might be sideways or it might be upside down. And so the models need to recognize if the data is flipped or manipulated in some way, or if it's smaller than anticipated. Maybe there's a picture of a piece of cereal and it's really zoomed out or something like that. So when we're working with images and we're creating those data sets, we want it to be able to recognize that item from different angles, at different sizes, in mirrored images, and that helps us to create a better data set for things. And so it's to create better data sets, but there are real world applications, obviously, for this beyond sorting cereal, even though maybe that is a very important thing to do. But what we know about it is that I had the study group last week. We were talking about this, and I forgot to look it up. But one of the women, Stephanie, in the group said that they took civil rights era photos and they added color to them. So they had been black and white and they added color. I saw a story somewhere where they were looking in, I think it was the Vatican archives, and they have all of these texts that need to be translated, but they're written in scripted language. I don't know, is it not called scripted language? Basically, it's an image for a word or a letter. And so it would take a really long time to recognize, is it JavaScript? It's ancient JavaScript, so whatever the prequel to JavaScript was, I guess. To be able to translate all of that, they had to recognize all of these different images. And so what they were doing was they were taking it into high school students, I think, who were scanning and creating the data sets so that once this is complete, they'll be able to go through all of these works in a much shorter time than it otherwise would have took. I want to say they said it would take like 100 years to translate all of that. And I could be wrong, but in my brain it felt like, wow, that's a really, really long time. And so even using it for something like translation, I wrote a blog post on image tensors yesterday, and I talked about Airbnb because they have one of the use cases. I don't think I have the link here. No, but it is in my blog, so you can find me on dev2 at Becca HW and check out my latest blog post. But in order to help verify what the hosts for their Airbnbs, what rooms they had, everybody has to submit their pictures, and so they'll run it through their model to identify, how many bedrooms, or to verify how many bedrooms or how many bathrooms that each of these has. And the way that it does that is, it'll look for something that's distinct in a room. So like, for example, a toilet. So we know most bathrooms have toilets. So if somebody said there are 2 bathrooms in this house and they submit these photographs of their Airbnb house, then there should be a toilet in those things. And so it would go through, you run the model, and it would be much quicker than if I went through there and did it manually. And so I thought that was a pretty neat use case too. I'll give you one more example. I was reading Deep Work by, now I'm going to blank on his name. And where did I put the book? The book is always near my desk, but I never know. Here we go. Not Deep Work. I read that too. Deep Medicine by Dr. Eric Topol. And I don't know if it was there or if it was on his podcast, but he's talking about using image classification as for medical diagnoses. So, for example, maybe they're checking somebody's kidney to see if it's healthy. And so with the data set, they'll compare whether or not that person, they'll know what a healthy kidney looks like, and they'll know what the disease that they're particularly looking for in that kidney would look like too. And so just like sorting the cereal, there would be a data set for the healthy data set for maybe some kind of kidney disorder. And to be able to run that image through the model, they have to take the image, it has to be translated into a tensor, and then they can classify it as part of that. So I think that there's a lot of really cool use cases for it, and this is kind of why I think it is so interesting. I am gonna try and adjust my camera here because I think I'm coming through blurry, and I'm just now realizing it. I think now I am clear again. Sorry about that. Okay, so let's go ahead and dive into a little bit more of what we're looking at and how we would do this. What are some methods? Well, we'll get to the methods because we need to break it down a little bit more. So let's see, what do we got here? Okay, that's just the HTML, and one day I'll create some cooler way of doing these things. I'm going to hit my Command B, my shortcut that Nick showed me to get rid of that side panel, and now I'm going to hit Command Z. No, it's not Command, it's Option Z to make sure that that all wraps. I don't know why that's not standard. Do people like it not wrapping on the on their text editor? That seems strange to me. Not sure what that use case is. Okay, so let's see what we can do with these images. All right, so let's first, okay, I have an example up here, I think. Yeah. So we'll walk through this code a little bit. All right, so if we want to create a new image, okay, so I have tf.randomUniform, and maybe these are the different things that we can do with it. tf random uniform. Okay, so this is what we're looking at here, and the first thing that we're going to do creates a TensorFlow tensor with values sampled from uniform distribution. The generated values follow a uniform distribution in the range of a min value to a max value. The lower bound min value is included in the range, while the upper bound max value is excluded. Okay, and so here are some of the parameters that we can pass. We talked about these different types last time. If we want to, we can go ahead and take a look at, we can just console log and see what we're dealing with here. So here we are, okay, so this method I have is called show image. We're creating a new image here. So we are actually creating from scratch. So we're not dealing with an existing image right now. We will do that in a little bit. But we're using this method that we looked up, and then we're going to post this to the canvas. Now we have this thing here called browser to pixels. And this is, I believe, taking that TensorFlow image, so that tensor, and converting it back to pixels so it's an image that we can see. So let's go ahead and click run and see what this image looks like. Nothing. It looks like a code sandbox that stopped working. Awesome. That is not, oh, there it is. Actually, so this might look wrong, but this is what we want to be seeing, which is basically like a fuzz screen from an old TV. And so there are other things that you can do to create tensors. Let's see what else we have going on here. Okay, let's see. I wonder if we can use this. Creates a tensor with values sampled from normal distribution. Well, we're going to try it out and see what happens. That's pretty much been a lot of how I learn with TensorFlow. Just try it out and see what happens. And that's why I've been going through and creating these code sandboxes for each of these, because I want everybody else to be able to do that too. I think it's fun. Oh, let's see. Must be in the range. Well, it would help maybe if I read through everything. Okay, so value sampled from normal distribution. An array of integers defining the output tensor, the mean of the normal distribution, the standard deviation. Oh, they have a little run button here. I never noticed that. Okay, so that's just giving you numbers. What happened? Did they have that down here too? Okay, so that's what the tensor looks like that we're doing. So we don't even need to console log. Well, we weren't doing a 2-2. We were doing something different. But let's go back here. Random normal. It says tensor value for a float 32 tensor must be in. Oh, I wonder if the problem is this third parameter. No, tensor values for a float 32. Okay. Well, maybe I just tried the wrong one, and that was not what I should be looking at. Oh, maybe it's got an issue because we're trying to turn it back to a pixel. So, I'm trying to think. There was another one that I wanted to go through that I don't have written down here. But we also have some things that we can do with tensors and images. Okay, so we also have array.prototype.fill that we could use. We'll go ahead and take a look at that here. All right, the fill method changes all elements in an array to a static value from start. I always forget to make this bigger. Sorry, from start to an end index. So we have, let's go ahead and see what happens when we do this. Okay, so we can remember that pixels are also arrays, that tensors are arrays. So arrays are our friend as we're learning TensorFlow.js. Okay, when you're calling the fill method, we can tell it what to do. I think that we've got this also in here, tf.fill. I guess there's a lot of things that are called fill. Okay, so this creates a tensor filled with a scalar value. I don't know if that's how you say it, scalar or scalar. But also that is an array. I believe scalar is the same thing as an array, but I could be wrong there. Okay, so an array of integers defining the output of the tensor, and then the scalar value to fill the tensor with. Okay, so the shape, that gives the shape, that gives the value to fill the tensor. So let's see here. Can we create this is tf.fill, and we also have, you can also use tf.zeros. There's where I wrote it down. tf.zeros, tf.1, and tf.fill. So I thought, I'll just throw this in the notes here. I thought I might have it. Okay, so we have these things. Let's go back here. Let's see. Maybe we'll do, okay, so we just read about tf.fill, so we'll stick with that. And we will say, okay, so we'll go to back here where we are meant to be. And then this is we're going to use the .fill method. And here we are going to make this much bigger. Make it 200 by 200. And then we don't have anything indicated here after this array. And so we see that we have a totally black box. Now, if we want to make this more transparent, remember we can add this third parameter, and we're going to make it 0.5 and then see how it's gray. Now, if you want to remember, 1 is totally transparent. So it's there, you just can't see it. We'll go 0.95. There you go, you can see it a little bit more. And then all the way down to 0, which is implied and gives you a black box. So those are some different ways that you can work with image tensors. sometimes when we're creating our data sets too, we might want to make things black and white, or we might want to figure out how to add color to things. And these are some of the methods that we can use to be able to do that. So again, like these are built-in methods, but what's fun is to just do some exploring, figure out what you want to do with it, how you want to play around with that. And I've seen people make some pretty cool artwork with code, and I've seen that there's I was trying to find this, but I bookmarked it somewhere. They take you can input an old art image, like artwork, like the Mona Lisa classic, and then apply a different style to it with TensorFlow, and then the output would take Mona Lisa and make it a different style of artwork, which I don't know very many styles of artwork what the names are, but so I'm not sure. Let's see, she can be minimalist. Is that one? We'll make a watercolor Mona Lisa. I'm not sure if that's exactly what you could do, but I thought that looked kind of fun just to play around with stuff like that. Okay, so this is how we create tensors and output them as images so we can see them. And this is a little bit more abstract, I think, as opposed to let's take an image and do something with that image. So we're going to go ahead and jump into that next. And so let's see. Hey, Jetty. It's good to have you here. It is morning for you, afternoon for me. We are just going over some image tensors. We talked about what makes an image. We talked about how to make a tensor an image. And now we're going to talk about some things that we can do with images. So let's see where we're going. Okay, so so one of the cool things is you can take all different kinds of data. So we're talking about images, but you can use videos, you can put things onto a canvas like we did here. There's different ways of working with this. And I know that somebody in our study group asked how video works with images in TensorFlow, and whether it's going like a still shot by still shot or if it's processing it in a different way. And I'm not sure of what the answer is to that. So if anybody has the answer, go ahead and let me know, and I'll make sure that I pass that information along. I meant to look it up, but this week got a little away from me. We were exposed to COVID, so we are all healthy but quarantined. So I've got kids at home, and they were very, very good yesterday. Today they decided that they were a carnival or something. I'm not sure. They were some kind of disaster going through my house. But anyway, happy to be healthy and to be here and to have some quiet right now. So let's see here. Okay, so I do already have an image loaded here in Command B. So I'll show you. I've got this truck JPEG. And we are going to go ahead and take that. And let's see. We want to first, okay, so the first step when we have an image is we want to take that image and we want to make it a tensor. So I'm just going to comment this out so that's not getting in the way while we go ahead and work through this. So we have this image. Oh, okay, and let's bring this back here just so we know what's going on. This is in the HTML. We need to make sure that we know where we're going to put this image. Canvas ID, this is where we were working with the image that we were creating. Now this time around we're going to have source equals, what is this called? Truck.jpg, PG. And I think that should work as we are working our way through this. Make sure I save it. All right. Now, actually, I should be able to see it already, right? If I imported that correctly, then we should see a truck JPEG. All right, now go away. Why? Well, the console go away. Okay, go. Nope. Oh, that little down arrow, that's letting you know that it should go away. Okay, so now we've got that to go away. Now we have to figure out why our truck is not showing up. Okay, so make this guy go away again. Nope, I don't want to keep clicking on you. No, stop. There we go. And now let's make this one bigger again, but we want to see this one. Okay, so we have image source truck. It was called truck, right? Yeah, it says truck JPEG. It's there. We can see it. It is in fact a truck. And we have ID image, we have source truck .jpg. Oh, that's right. Because I just tried to use something else. Oh, good call. Sorry. Thanks, Nick. All right, there we go. All right, so we have not formatted this in any way, so we've got this humongous looking truck. We can do, shape this up a little bit. Oh, we've got to add some stuff to it. Style equals, let's give it a width of 50% and a height. Well, that's fine. We'll just leave that like that. Okay, so one of the things that you have to make sure that you have when you are working with it in this way, you have to have cross origin equals anonymous. So, and that will be when we're working with it as a tensor, because otherwise it won't run most of the time. I think that there are certainly exceptions there, but just to be safe, add that in there. And now we've got an image that we can play with and we can make it a tensor. So we go back to our index, and what is the first thing that we need to do? We know that step one is turn image into a tensor before we do anything else with it. Okay, and so we turn an image into a tensor by, whoops, not being capital, tf dot, oh, first we have to make sure that we can grab that image from the browser. So let's just call this truck image. Truck image equals document dot get element by ID. Nope, click the wrong thing. Element by ID. Okay, and I think that the ID was just image. Okay, so now that we've grabbed it, now that we know where it is, now this is how we can make it into a tensor. Const truck. Truck tensor equals tf.tensor. And nope. Is that what we do? Oh, we need to grab it first. Let's see. Let's Google this. Make sure I'm doing it right. TensorFlow, TFJS, images, image to tensor. Hey, look, isn't this great? So this is the first page when you Google TFJS images to tensors. Gant's book that I'm using is number 1. The third one is the blog post that I wrote yesterday. So I feel very accomplished now because I'm sure that there are many people that run that Google search and I am the third result. So, Nick says that Dev has really good SEO. Well, shout out to Dev for, actually, this is from my personal site, but, it lists it from my site too, because I post to Dev too. I cross-post to Dev too. So I always post everything on mine first and then cross-post over there. So the canonical URL. That's what it's called. That sounds very fancy. Let's see. Convert images to tensors using tf.fromPixels. Okay. So let's say from pixels. Whoops. All right, so this says tf.browser from pixels. Pixels. I always say pixels, but I've been hearing people say pixels. So I tried that out too. I don't like it, so I'm not going to say it like that anymore. Okay, so the input image to construct the tensor form. All right. That's weird. Oh, okay, from pixels. There we go. All right, so we're doing it from pixels. We can do it to pixels as well. So we'll do tf.browser.toPixels, and then we're going to pass it that truck image. And it's going to say, you're wrong. You're not allowed to do this. Argument image passed to pixels must be a tensor. Oh, and I just did the wrong thing again. From pixels, yes. All right, now I know what I'm doing. Okay, so now we have the truck image. We are going to turn that image into a tensor, and now we should be able to use the methods, the TensorFlow methods, to do some stuff with the truck. So I guess there's really not a step 2, but I wrote step 1 already, so we're going to write step 2 just to make me feel better. Manipulate tensors. How about that? Can that be step 2? I think it sounds good to me. So, all right, so we talked about why we would do some things, and we talked about augmenting our data sets by using some of these methods. So that's what we're going to go ahead and do here. So we have this truck. We're going to go ahead and why don't we reverse it? I really so badly wanted to use the Missy Elliott reference, but Kirk already has claimed to the Missy Elliott reference. Kirk from Virtual Coffee created a function, I think it was called flip it and reverse it, and somebody tagged Missy, oh my gosh, Millie, all right, slow down, Missy Elliott on Twitter, who's the rapper that Rhapsody song, and she replied to Kirk. So anyway, he became internet famous, and so now we're not gonna flip it and reverse it with tensors because he already has laid claim to that. So we are going to go ahead and reverse it. Let's see. I wish that this was, I know that it's nice that this is alphabetical, but I would love to have it categorized according to like images or audio or whatever. But it's not, so that's a project for a different day. tf.reverse. Here we go. Okay, so we can reverse it along a specified axis. So here we go. So they have a one-dimensional tensor there. And I guess we could console log what shape our tensor is. That might be interesting to look at. So we'll go ahead and do console.log and truck tensor and see what we've got here. Oh my goodness. Go away. And lots of stuff, but this is what we want. Okay, so we've got this array. It is, that's weird. I don't know if you saw that on the screen, but everything just went kind of wild. It went into chaos mode. So we've got this shape. It is an array, a 3D array. So we have a rank type of 3. And it's interesting that the data type is an integer because if you remember from last time or maybe the time before, float 32 is the default. So I guess that's how we deal with images. Now it's something I want to look up because that's interesting. Okay, so that's what our tensor looks like. We've got 114, 155, and 3. That's really interesting. Okay, now I'm going to remember to click the little down arrow, and that's gone. So let's do something with this. We're going to reverse it, right? And I so badly just want to do Miss Elliott. I really wish that I could do sound effects and that like I could hit a button and it just played that part. Anyway, I'm going to stop talking about that. Okay, so we have these parameters. We're going to go ahead and reverse this, which does not have an axis parameter. Okay, so we're not, I guess we would be a reverse 3D, but I think we can just call TF reverse. We'll go ahead and see. And we are going to reverse our truck. So const reversed truck equals tf.reverse. And then truck tensor. Oh, nice. I forgot that this has all this built in, so we don't have to keep going back and forth and looking at the docs. Reverses a TF tensor along a specified axis. Oh, also available are stricter rank specific methods that assert that X is of the given rank. That's interesting. So we could just use regular reverse. And we are going to specify the axis here as 1. And now we need to, let's see. We need to turn this back into an image. Yeah. Okay, so this is the tensor. This is reversing it for us to see it, it needs to go back to the state of the image. Oh, maybe there is another step. Okay, manipulate the tensor. And then we have, maybe this is step 3 then. Step 3. We are going to return to image. We are going to do, okay. Did we, let me just save this, go back here and see what we've got going on here. Oh, okay, so we had this canvas ID new image. We can just reuse this, I think, to run this. We'll go ahead and click the run button because why not? It's fun to click it. And we'll go ahead and throw it in this canvas, which I think we can do. So maybe. Okay, what was that called? New image. Yeah, all right, return to image. Const. I'm running out of things to call this. We've called it everything. Reverse image. I'm sure we could refactor this and make this much, much cleaner, but we're breaking it down in 2 steps right now. Equals tf dot browser dot, okay, so this time we're going to go 2 pixels and we're going to pass that. Okay. All right, a rank 2 tensor with the shape, height, width, or a rank 3 tensor with shape, height, width, number of channels. Well, we've already got that, so we've already got this as a sort here. So that takes care of that. But we also need to put it somewhere. So we need to put it, I guess, on that canvas. Did we already define that canvas? Okay, so we have image. No, we have the new canvas. Return to image and canvas. This doesn't really make sense, but it helps me understand what my head is thinking. All right, so let's go ahead and grab that canvas too. Const canvas. So we're not going to use that button. Equals document dot get element by ID, and that was called new image. I am AGE. I can't remember if I gave it the whole word. New image, yeah. And then we're going to pass this canvas. And we're going to spell it right. And so now we have the reversed image. Okay, so again, this is how you can reverse things. You can use different methods to batch your data and see what that looks like. There's also a method for cropping. You can do, let's see, resizing. So maybe we'll do one more and then we can call it a day. So okay, if we batch crop, that is a whole, we don't have a batch. So let's look at resizing. Okay, so sometimes your models will expect a certain size, and so you need to make sure that the data that you give it is that size. And so this is another way that this can be useful. So If your model expects 256 by 256 and your user uploads something that's 700 by 900, then we go ahead and we do an image resize. So let's see here if we can find image dot crop and resize, or let's see. Crop and resize extracts crop from the input image and resizes them using bilinear sampling or nearest neighbor sampling to a common output size specified by a crop size. Or flip, oh, we can flip left to right. Oh, hey, look. Remember how I said I wish that they all were sorted by category? These ones are. Because it uses tf.image. So, interesting. Okay, our nearest neighbor, resize nearest neighbor. What does this do? Resize a batch of 3D images to a new shape. Okay, we don't need to go through and do a batch. Oh, we can also grayscale it, converts from grayscale to RGB. Huh. Interesting. Performs non-maximum suppression of bounding boxes. We'll talk about bounding boxes in the future. I'm really excited to get to that. Okay, we are going to go to crop and resize like I originally said, and I will, again, stop being distracted. Oh, hey, Ian. Yes, exactly. This is what we were going for. We are trying to help them recognize each other on the road. This is for the future of trucks controlling and driving themselves, I think, maybe. But we can imagine whatever dystopian future we would like here. It's always okay. Within reason. Code of conduct. Hashtag. Okay. So, crop and resize, right? I really wish that the chat had a notification. Maybe that would be really distracting. I guess if you're really popular and there are lots of people talking in your chat, that would be distracting. But I don't have lots of people, so a ding every once in a while would be useful to me. So I am going to refocus here, and we are going to crop and resize this big truck. Oh, and there was a little beep in my headphones because I forgot to shut down Discord, which I'm surprised my computer's not trying to blow up right now. Okay, so image, tf image dot resize. So resizes them. I want, oh, interesting. Crop and resize. Is that the one that we said? Oh no, we were down here. Resize by linear, right? Maybe? Resize a single 3D image or a batch of 3D images. Okay, so maybe that is what we want. I am really an example person. So when I am reading documentation, I would love to see an example of what this looks like. So how should this look? Yellow, apparently. That's not really what I wanted. I just want to see an example. Resize by linear example. I guess usually there's some example in Stack Overflow because somebody's got a question about it and then somebody tells them the right way to do it. So let's just see if we can figure out the right way to do this. The results are quite different from that. Okay, so I don't really care. I just want to see what you did. Okay, that's the C 2 thing they were talking about. TF image.resize by linear, B resize shape. Where is the resize shape? Wow. Okay, this is, oh wow. So there you go. There is something that has nothing to do with what we're going to be talking about, but there's definitely other things happening there, and that is not what I want to get into. I just want somebody to show me what it looks like. Okay, images, size, alignment, corners. Oh, look, there is Pete the cat. Stated, okay, so we know what our image is for sure because we've got that here. We've got a truck tensor. So if we want to const resize truck equals tf.image.resize by linear. Okay, give me my nice little thing here. Align corners. Okay, we are going to pass it truck tensor. It's not letting me scroll down. There we go. And hi, IU. All right, we're passing it a truck tensor, and now it is mad because what do we need to pass it? Reading. Okay, so we've got to pass it a length, and what's the thing? Nope, that's not what I want. Not what I want. This is what I want. Okay, image size, the different stated configuration, new height, new width in order to rescale the images. Every channel is rescaled 1 by 1. Okay, so let's scroll down and see if they do have an example. Okay, yes, they do. Okay, so I would imagine that this first, okay, so this is their tensor, and then this is what they want it to look like, right? I'm pretty sure. So this would be the next thing that we need, 3, 4. So, okay, so let's take a look at, let's comment this out for a minute. Where did we console log that truck tensor? Here. Truck tensor dot size. Oh. Image size. So and this is output. In this example, we're going to use an array of floats, aligned corners, as well as half pixel centers. TensorFlow.image resized by linear. So they have that array, that is their image. Oh, okay, so they're passing all of these parameters, and then that is what it ends up looking like. All right, well, we will go ahead and let's pass it the new shape, so new height and new width to resize the image too. Okay, well, let's just do what I like to do and play around and see what happens. 1, 2. All right, so we should now let console log resized. Okay, so here is what the first tensor looks like. I should break this down into a way that's clear. So let's see. It's an integer. We have a size 50 to 83, an array. The shape is an array of 3, or a 3 rank. And now what do we have here? Resized. Okay, so this is interesting. It's a float 32 rather than an integer 32. So there must be something in that method that changes that. And what do we have here? A size of 6 and an array of, the shape is 1, 2, and 3. Interesting. I'm not really sure how that got changed to that, so I would need to dig into this more. I am not sure if this resize truck, if we can print this or not, or well, we definitely could print it. Let's see. That's not what I meant though. Can we, instead of having the reverse truck there, can we make it an image? Will it look different? I mean, I would think. Tensor values for a float 32 tensor must be in the range of 0 to 1, but encountered 175. Okay. Interesting. Tensor values for a float 32. Oh, remember last time when we did the reverse truck, it is not a float 32, right? It is a, let's see. Actually, we didn't console log the reverse truck. Let's see what comes out when we say, not that. Reverse truck. All right, let's see what we discover here. And that would be this one. So that's an integer 32. And so I guess the method that we use here for, which one? The resize truck, this turns it into a float 32, which by default, remember, a float 32 is the default type. So it's interesting what is going on here. I imagine that we could go back through and change this. So, okay, so what we have learned, though, however, is that we cannot convert that. We're not going to look at that image right now. We can't convert it just this way, but what we can do is, what is going on here? Oh, this is still here. We still do have that reverse truck. We've lost it. There it is. We have learned to reverse the truck. And sometimes you can simply change it and see it, but sometimes what's really happening behind the scenes in the console log when we look at these is the information that we're going to use with the models. So it's fun to be able to look at these different things. There's ways that we can make it black and white, and maybe that's the direction I should have gone in. We should have made it black and white instead of cropping it. you saw in the console that the numbers were significantly different. And so that would allow the model to do other things with it. But what we have here is just different ways to manipulate these and to think about how we can use these in our models, which we're going to discover a lot more of that later. I think next week, what are we doing next week? We are doing, we're learning more about models. So we're going to dive into some really fun stuff, learn how to apply a lot of the stuff that we've learned to using it with models. And I don't know which model we're looking at for sure, but I think that this is probably a good place to stop today. We got a couple of things working. We discovered that things sometimes look differently than I expect them to look, and diving into the documentation. And actually, what I might start doing, again for me, trucks are fun. What I really like from documentation is examples. So maybe as I'm going through more of these methods that we're using, creating some examples, because if you're like me, then you can find them in my blog post on the first page when you Google the very specific thing about TensorFlow.js. But thanks everybody for coming and for listening today. There wasn't anything super big or exciting, but we did learn how to reverse a truck. We learned how to create some tensors and convert them to images. And we will be back again next week talking about models. So thanks for being here, and I'll talk to you all later. Bye.